okay, so explain to everybody who's watching and listening how you're involved right from the place where the uranium is still in the ore in the ground. Like, what has to happen at each step along the way so that the fuel actually gets to one of your reactors, and how is your company situated to make that happen, and where are you in that process?
So starting at the very basic, uranium mining, you mentioned the Saskatchewan deposit. So you mine the uranium, but the ore is effectively not very useful for anything, but you subject that ore to a leaching process, and you create a yellow cake, which is essentially more concentrated uranium that then would be shipped off for a conversion. Where we sit in that is that we've actually reached out to Central Asia, where almost the majority of the world's uranium is currently being mined. It doesn't have to come from there, but say there are big deposits in like Wyoming and Saskatchewan that are not producing uranium readily now in enough quantities to meet the demand. And so it is coming from abroad. I believe those domestic deposits will be built up now that the uranium price is rising, because like COP28 announces the necessity to triple nuclear energy by 2040 or whatever it is. So that is having an effect on the uranium price, which is encouraging mine development. But the problem with mining is that it can take 5 years from a greenfield deposit to get to a mine. And so you always have that lag. And if during that lag, the uranium price drops, then that can even hit that mine even coming to commercial production. So there's a lot of risk associated with, not having your own domestic facilities in place. So we have reached out to them. We do have an ability at the President's office within certain countries in Central Asia to source uranium directly if we should need it. And we've even talked with the largest uranium materials broker in the world to make sure that we have a supply of that, because no business wants to have the risk that you build all these facilities and reactors and manufacturing facilities, but the raw material that fuels all this isn't there. So that there's that component to it too.
Well, do you worry that you're dealing with these, like say Central Asian? See, again, it brings me back to the same thing. Well, if you could have a resource in Wyoming, or let's say in Saskatchewan, that seems to me to be a lot more geopolitically stable in any real sense than trying to source something halfway around the world in countries that are definitely not politically stable. And so why were you compelled to go seek out suppliers elsewhere?
Well, it's the immediacy of supply. Like, they are able to supply material now. And that is a major advantage over, we have a mine and it's at even feasibility level. You still need to put the mine works in place, the processing plant in place. Processing plant from uranium operation could be $250 million and take 3 years to build. And so we want to make sure that...
Does it have to take 3 years to build? I mean, because things do move a lot. They could move a lot faster now than they once did. And I also wonder, are there improvements in technology that are in the pipelines that would make it possible to do it in like a year instead of 3 years if people actually decided Germany built new natural gas importing terminals in months when they needed to. So like, we can actually move pretty quick if we decided it was a good idea. So, okay, so you said immediacy of supply. That's what drove you to Central Asia. But it would be better, perhaps, if there were domestic supplies that were at least in the pipelines, let's say.
Domestic supply from Saskatchewan or Wyoming would be a lot better. Of course they would. There's no geopolitical, there's less geopolitical uncertainty. And like, for instance, even in Central Asia, like, they do supply China and Russia still with the uranium that they need for their own programs too. So you're competing against other countries which are potentially hostile to the States or Canada or places like that. And if they're looking to wage an economic war, we'll look for more exclusive contracts. And so you then are in a competing position for material you can't control.
Right. Seems like from a geopolitical perspective, that seems unwise. Let's put it that way. So I can understand why you guys are doing it commercially, because as you said, you can't afford the delay, and fair enough. Okay. So now, do you have a stable supply fundamentally? Can you get moving with what you're doing?
We can. So, the good part about what we're doing now is we've ensured that we have brokered enough good relations with certain countries that we can source the material if we wanted. We're not in the business of enrichment, but we could do things like conversion and get it into a uranium hexafluoride gas, which can go to a licensed enrichment company like Orano or Centrus, and they could enrich the material for us. And once
from
they've
gas. So what's the relationship between the gas and the yellow cake?
So what you want to do with yellow cake is once it's been concentrated by that leaching process, is that it's easier to enrich a gas than it is, say yellow cake, which you could use a centrifugal system, but gas is certainly a lot easier to maneuver. And so if you would take the yellow cake and you would expose it to several chemical processes to turn it into uranium hexafluoride. And it's actually the enrichment companies will enrich uranium hexafluoride to produce, whatever you want. So enriched to whatever level the customer needs it. But at that point, it actually needs to be deconverted back to a solid.
Oh, yeah.
So our company actually wants to build out that infrastructure for the country too. So take that uranium hexafluoride, convert it to uranium dioxide, uranium hydride, uranium metal, whatever the market will need. And so that's one element. And then fabrication facility to tailor it for the specific reactor. So essentially fashion it into dimensions, composition, mold it with zirconium, whatever they want, and then sell that. And the final part of what we want to do is build out a transportation company, so we can actually transport that around North America too. So
how would you transport it?
So we've actually been spending about a year doing this, but we've got a patented technology now for a cask system that can transport the most amount of enriched material, so HALEU material, so it's enriched up to almost 20% around North America. And we're just in the process of getting that license now with the regulator.
Okay. So that's okay. So you've been working on solving the transportation problem. And so what are the problems associated with transport that you've had to solve? And how did you solve those?
So the fundamental problem with transport is that you cannot have uranium critically configured. And what I mean by that is if you uranium is only actually really radioactive if you push it all together, which is the basis of a bomb, really. If you push it together, then it triggers itself more and it sets off a chain reaction, and the reactivity creates the heat. So effectively, for road regulations, you have to store the material in a structured way to make sure it's not critical. But it doesn't end there. There's a lot of other regulations surrounding that. So is it going to be hit by a plane or a missile, or is it going to fall underwater, or is it going to fall? Or what are the heat conditions? Can it be cold? Can it be warm? And you've got to make all of these safety scenarios. So designing a transportation cask that fits within a truck that can move a lot of material by road is a bit of an engineering challenge, but I don't think it's that difficult. But it's certainly something that has not been in place previously, because for SMRs and microreactors, the uranium is enriched slightly more. And because it's enriched slightly more, you need a completely new cask system. And so that's where we thought, we'll jump on that and build that out. And that way, when the industry does take off the SMR microreactor, we will have the transportation able to move fuel for all the SMRs.
So does that mean, I see. So that means that your transportation system in principle is not only designed to service your microreactors, but to be expanded to service these slightly larger reactors, the SMRs.
Yeah, the good part
is... And that's the plan.
Yeah, that's the plan. So we're not in the business where we want the other competitors to fail. If they win, we'll win.
Right. Yes. Right. Absolutely. The right number of competitors isn't zero.
No, exactly. Yeah. And also we want them to succeed, because they'll build out the infrastructure, they'll generate more money within the country for this industry, and we'll be beneficiaries of that too. And they want to move fuel, we'll help them move fuel. They want to fabricate fuel, we'll fabricate it for them. Even if they outsell our reactors, it's fine.
Right. So you can also be in on their success in that situation too. So that's cool. Okay. So you said you've got a supply, at least at the moment, in Central Asia, that gets reduced by leaching to yellow cake. The yellow cake is transformed into uranium hydro. What's the name of the gas?
Yeah.
Hexafluoride, uranium hexafluoride. That can be concentrated and then converted back into about 20%. You said And so why 20%? And you can transport it at 20%, and you can do that safely. And you can do that by rail, by ship, by car, or by train. And so now you have the 20% enriched material. What do you do with that when you get it to where it's supposed to go?
So it depends where it's going. So if it's going to, if it's the 20% enriched uranium hexafluoride, that'll need to be converted into uranium dioxide, hydride, or whatever fuel form you want it, effectively.
Okay. So are you transporting the gas?
We don't want to. I don't want to speak preemptively.
Okay, that's fine. Yeah.
But actually, no, it's fine. We do want to take our cask and modify it so it can move gas.
I see. Okay.
The anticipation is that currently we are building out a deconversion plan to be able to convert that gas into other forms. And then when they're in other forms, it's easier to fabricate into the final uranium form that the customers might want.